Hi Heron and Riverside students, I am Miss Feck, and today we're going to continue talking about nomenclature. Last class you should have watched a video that Miss Gardner made about how to write our names after we see a chemical formula, and we're going to continue talking about nomenclature by talking about how if we see the chemical name, the chemical compound's name, how can we write the formula. So make sure you have your notes out and write nomenclature part 2. So Ms. Gardner talked about ionic bonds, and that is when electrons are transferred from one atom to another atom. We will be talking about this way later in the year, but what you guys need to know right now is ionic bonds are between a metal and a nonmetal. And one example of this would be LiF, we would call lithium fluoride. Notice that lithium is a metal, and that comes first, and then fluorine is the second element. We change the ending to IDE, and with ionic bonds, we have no prefixes. Since there are no prefixes, how would we write the formula? How would we know how many of each compound, or of each element, do we need in the compound? And what we do is we crisscross the charges. So here we see lithium will have what's called a +1 charge, and oxygen will have a -2 charge. A charged atom is called an ion. And so what happens here is we crisscross the charges. And so since this is a +1 charge, we're going to need 1 oxygen. And since this is a -2 charge, we're going to need 2 lithiums to get lithium to oxide. And how we can think about it is now we have 1 -2 charge and 2 +1 charges, because we have 2 lithiums. So our charges cancel out. Well, how would we even know what the charges are? We can look at the periodic table of elements. So sketch a little periodic table of elements in your notes, or grab one out that you have. And notice that group 1 always has a +1 charge. Everything in this group has a +1 charge. Everything in this group has a +2 charge. These charges change. Our transition metals change charges, so don't worry about those right now. And then the boron group has a +3, then a +4. And then these can be plus or -3. We'll mostly see them as -3. And then -2, -1, and 0. So again, notice that we're getting higher and higher until we get to the carbon. It's +4, and then we go to -3, -2, -1. So when we need to write ionic compound formulas, our first step will be to write the element symbols. Step number 2, make the symbols ions. And again, ions are charged atoms. We will find the charges by looking at the periodic table of elements, and the cation goes first, which is the metal. Next, we will crisscross the charges. So I just used the word cation. What in the world does that mean? Well, we said an ion is a charged atom, and specifically, a cation is positively charged ions, and an anion is a negatively charged ion. This is how some people like to remember it. Cats are good. They are positive. Notice that they have the positive signs. Onions are bad, or anions. Onions sound like anions. Those are bad. They are negative. Or I've heard people say cations are positively charged, kind of like cats. So if we apply those steps, here is an example. So if we needed to write calcium chloride as a chemical formula, we would first write the element symbols. I look at the periodic table of elements, see that the symbol for calcium is Ca, symbol for chlorine is Cl. Then I make these symbols ions. I need to find the charges by looking at the periodic table of elements. So if I look at my periodic table of elements, I find calcium. Calcium has a +2 charge, and chlorine has a -1 charge. So therefore, we have a Ca +2 charge. Cl has a -1 charge. So now I just need to crisscross the charges. Therefore, I need 2 chlorines, 1 calcium. So my final answer is CaCl2. Pause the video and write these steps down. Next, if I looked at aluminum oxide, I would first write the element symbols. I would make these symbols then ions. If I look at the periodic table of elements, I would find aluminum has a +3 charge, oxygen has a -2 charge, and now I crisscross the charges to get Al2O3. Again, my charge from my oxygen, becomes my subscript here, and my charge for my +3 becomes the subscript here. One important thing to note is superscripts are when they are raised higher and subscripts are down below. So superscripts on top, subscripts on the bottom. This denotes how many atoms I have. Next, if I were to do sodium oxide, I would see that Na has a +1 charge, oxygen has a -2 charge, so I just flip them, so Na2O1. Now talking about covalent compounds, switching gears a bit. Covalent compounds is when we share electrons, and again we'll talk about this more later in the year, but hydrogen, H2 is 2 nonmetals together, or it happens to be the same thing, but hydrogen is a nonmetal, so they are sharing their electrons. And our steps for this is we just need to write the element symbols and then add the subscripts based on the prefixes we see. For example, for carbon dioxide, we have carbon and oxygen, because oxygen gets changed to oxide, gets changed with the IDE ending. So I have C and O. I add subscripts based on the prefixes. So since we have a di, we know that means 2, so we have CO2. Or if we wanted to do dinitrogen monoxide, I would think, okay, I have nitrogen and oxygen. I need 2 nitrogens because it's a di, 1 oxygen, so it would be N2O. Next, dichlorine heptoxide. Chlorine is Cl, and I would get this from looking at the periodic table of elements. Oxygen again is O. Therefore, we have Cl2O7 because our di is 2, our hept is 7. That is the end of today's notes. Make sure you write down any questions that you have so that they can be answered next class. Thank you.